Another type of inequality is quadratic inequality, having two roots or values of x. Check out how the ranges of this variable are determined here in Mathematics of Engineering. To understand the procedure of solving quadratic inequalities, we revert back to the quadratic equation ax squared plus b of x with c. There are different ways to find the roots of the equation, such as factoring, by using the quadratic formula, and by completing the square, among others. In this video, we have a few examples of quadratic inequalities solutions. Let's start with x squared plus 9 is greater than 6x. We complete the three terms of the inequality by subtracting 6x on both sides, giving us x squared minus 6x plus 9 is greater than 0. The coefficients of the expression allow the method of factoring to find the roots in which we can find x minus 3 squared is greater than 0. The next step is to equate each term with 0, although in this example, we have a repeated value of x. We continue by adding 3 to both ends to have x is greater than 3. This we can graph by placing an open interval on 3 and an arrow directed to positive infinity. Then, write the interval notation for the inequality as an open parenthesis with 3 and pair it with a positive infinity, then close parenthesis. The second example is with x squared minus x is greater than or equal to 12. The inequality should have all three terms altogether, so we subtract 12 on both sides and we get x squared minus x minus 12 is greater than or equal to 0. Again, by factoring, we get x minus 4 and x plus 3, and they are greater than or equal to 0. Separate two terms and equate each to 0, so we have x minus 4 is greater than or equal to 0, and the other is x plus 3 is greater than or equal to 0. So getting back to the former inequality, we add 4 on both ends to arrive at x is greater than or equal to 4. The other inequality will be subtracted with 3, so we get x is greater than or equal to negative 3. When we place the ranges in the number line, we would use close intervals on both negative 3 and positive 4. And since both inequalities are supposed to be greater than, the arrows will be pointing to positive infinity. Having this illustration for the answers is quite confusing. So instead of immediately drawing arrows, we just take the ranges as markers in the number line and use them as the limits for each set of tests to check the values for the inequality. For this example, we do have 3 sets of tests to make and check which falls true for the inequality. First, we think of a value between negative infinity to negative 3. Say we take negative 4. We plug this value into the equation to come up with 20 is greater than or equal to 12, which is actually true. For the second range, within negative 3 and positive 4, we again assume an x value of 0 and plug this into the inequality, then we come up with 0 is greater than or equal to 12, which we know is false. The last range has a lower limit of 4 and extends to positive infinity. Say we take 5 and placing it in the inequality, we get 20 is greater than or equal to 12. This is a true inequality. So now, we can illustrate it more clearly by showing the true inequalities, one of which is between negative infinity and negative 3. The other is between 4 and positive infinity. So in interval notation, we write the two ranges as the union of negative infinity and negative 3 with 4 and positive infinity. The third example is with x squared less 1 is less than 0. Having two terms of perfect squares, we use the difference of two squares to find the roots, which for this example are x plus 1 and x minus 1. After finding the two terms, we can now proceed to x plus 1 is less than 0, and by subtracting 1 on both sides, we get x is less than negative 1. The other is x minus 1, which is less than 0. So we add 1 to both sides to get x is less than 1. Graphically, we only mark the x values of negative 1 and positive 1 with open intervals. To limit the ranges of x, we check certain values again. From the range of negative infinity and negative 1, we take x as negative 2. Using this in the inequality as value of x, we get 3 is less than 0, which is false. The second range is between negative 1 and positive 1, so we assume x is equal to 0. And plugging this value in the inequality, we get negative 1 is less than 0, and this is a true mathematical statement. The last range is within positive 1 to positive infinity, so might as well use x is equal to 2. By substituting 2 in the inequality, we have 3 is less than 0, which is again false. Now, the illustration is clearer. The adopted range falls between negative 1 and positive 1, and this can be denoted as negative 1 and positive 1 and closed with parentheses. The fourth example contains 7x squared plus 11x plus 4 is greater than 0. With a more complex set of coefficients, it would be easier to have this solved using the quadratic formula, with a as 7, b as 11, and c as 4. And by simplifying, we get the first root of x as negative 4/7 and the second root as negative 1. Don't get so excited finding the equal sign this time. This is only to identify the limits we are going to use in the number line. Furthermore, since we have a greater than symbol in the inequality, we mark the roots with open intervals. Observe that we have three ranges of x again for the inequality. Within negative infinity and negative 1, we can use the value of negative 2. Using this in the inequality, we have 10 is greater than 0, and this is a true statement. The second range is between negative 1 and negative 4/7. We try negative 5/7, and plugging this in the inequality yields negative 2/7 is greater than 0, which is false. The last range falls within negative 4/7 and positive infinity, so we take x as 0. Use this value in the inequality and have 4 is greater than 0, which is again true. Now we can place our values clearly in the number line. And now, we are sure of where to place the arrows from the open intervals, one of which is directed to the negative infinity and the other to positive infinity. This can be noted as the union of the range negative infinity and negative 1 and the range of negative 4/7 and positive infinity.